All right, so I'm going to be talking about measuring distances in space, which is a surprisingly difficult question and also a very controversial question in astronomy, even though it seems like it should be so simple. So measuring the distance between me and maybe the camera is pretty easy. You know, you take my height, you figure it out. I'm about 5 feet tall, which is why I'm not standing behind this. And it's pretty easy to figure out maybe this is like 20, 30 feet. But if we extend it further to Baker Berry, that's much more difficult to approximate my height and figure out the distance. But one way we can do this through a special type of star that I'm going to explain through an analogy. So imagine you are with your friend, and your friend has this special whistle. The special thing about this whistle is that it's always the same loudness. No matter how you blow it, it always sounds the same. So if your friend is next to you, you know how loud it sounds. They stand 5 feet away from you, you know how loud it should sound. And you can calibrate this ruler. Now, you go make them stand really far away, maybe Baker Berry, maybe somewhere in Vermont. You can listen for that whistle. Assume it's very loud. I feel very sorry for your friend. But the whistle is very loud, and you're able to figure out how far away you are from your friend. So that is one way to come up with a ruler, is through this whistle. But let's say this whistle is not necessarily the only whistle in the world. There's lots of whistles, but all these whistles have a very specific property that all whistles adhere to. So depending on the pitch of the whistle, depends on how loud the whistle is when it's right next to you. You know, this is very lucky that all whistles do this. So now, if you listen to an arbitrary whistle, you listen to what pitch it is, you know, if it's an A note or a C note, and you listen to how loud it is, and you can figure out exactly how far away it is. And this is very important in astronomy. There's a special type of star called RR Lyrae stars. They're variable stars, which means they get brighter, dimmer, with a very, very specific period. They're very good clocks. We figure out this period, and the period is actually related to how bright they actually are. So in astronomy, we can measure how bright it appears to us, but knowing how bright something actually is very, very difficult. So what we do is we figure out the period, which is very easy to measure. You just watch it a whole bunch, and you can figure out what the period is. We know how bright it should be, and now we can figure out how far away it actually is. So what I do is I actually calibrate these stars. We don't actually know the period, how bright it is, that relationship very well. We need to do this with stars that are very close to us, that we can figure out the distance much more easily. So this has already been done with one set of stars. The issue is it's very controversial. It doesn't agree with actually what cosmologists and physicists agree with. Astronomers have their own idea of how big the universe is. So what we're doing is we're using a different type of star. We're figuring out how far away they are. You can extrapolate this out to very universal constants. We can figure out the age of the universe, the size of the universe, just using this very simple measure. But hopefully, in the end, we'll either agree with one or the other, or maybe we'll find a third result. We're not very sure. So measuring distances is really hard, and it takes a lot of work, and it's going to take me probably 6 years here at Dartmouth. Thank you.